not already watched it, make sure you watch the first of the videos first on how to set up multi-step conversion. And this is the one where we're going to apply those skills. So the first thing is we got to read the question. Sia's breath, Sia is an awesome singer, is she breathes in 5.63 liters of air. How many molecules of nitrogen are in this breath? Although you might not initially be comfortable with the terminology here, we want you to think about using the skills that we talked about, finding inequalities, setting up conversion factors, converting from our starting quantity to our quantity that we need. Those are the skills we're applying, regardless of if you know what these terms mean, and we're not assuming that everyone does. Go ahead and pause the video now and do your best to work through this problem, identifying those conversion factors and applying them. Now, hopefully you've worked through the problem, and the first step, as we did before, was let's identify the starting quantity in unit, and then what we're trying to get to. So I see the starting quantity. We know how much she breathes in. Sia breathes in this amount, and so it's 5.63 liters of air. So this is our starting quantity. We're trying to figure out, well, what is that in another unit? We're not saying it's a different amount, but we're saying how many molecules of nitrogen. So this is our unit that we're trying to get to. But then we need to have some conversion factors, right? We need to somehow go from liters of air to molecules of nitrogen. There's a lot of steps there. So then let's look below, and let's try to figure out what all the conversion factors are that are hidden in this text. So one of the most challenging ones is actually this first one. Nitrogen is 78% of the molecules we breathe in. And if I were to write this out, I would actually write out that if we have 100 molecules of air, that is equal to 78 molecules of N2. We're not saying that it's all of them, but 78 out of every 100 molecules of air are nitrogen. We can make a conversion factor out of that like we've done before. And then we have Avogadro's number states that there are 6.022 times 10 to the 23rd molecules for every mole. So we know that 6.022 molecules is the same as every mole. So that's 1 mole of molecules equals 6.022 times 10 to the 23rd molecules. Let's look for another one. So assuming standard temperature and pressure, it's required for this next statement, 22.4 liters of any gas, which can be air, contains 1 mole of molecules. So we could say that 1 mole of molecules is equal to 22.4 liters of that gas. Okay, I think we pulled everything out that we might need. So I'm going to go ahead and try to do a blank screen behind this. And I'm hoping that if I erase this top part here, we can use these conversion factors in order to do this problem, and I'm going to try to leave those at the bottom. Okay, so what was our starting quantity again? Our starting quantity was 5.63 liters of air. And it's really important that we write air and we write it over 1. So our first step is we need to figure out how to go from air, convert that into liters of air to another unit. And the one that stands out is that we have liters of any gas. So we know that if we have 22.4 liters of our gas, we're going to say is air. We know that that is the same as 1 mole of molecules. So this is our blue conversion factor here. We took this and wrote it out as a conversion factor. The next thing that we want to do is we've now converted from liters of air to molecules, moles of molecules of air. And then we want to say, well, how do we go from moles of molecules of air to just how many molecules there are? So the next thing we need to do is go from moles, so 1 mole of molecules, I'm going to abbreviate that, of air, is equal to 6.022 times 10 to the 23rd molecules of air. go back, make sure that that conversion factor was written appropriately. Mole molecules of air, mole molecules of air. Now we need to see, so that was our green conversion factor. Finally, if we know the molecules of air is what we have now, we need to go from molecules of air to molecules of N2. And luckily we have a third conversion factor that will allow us to do that. So I'm going to write multiplication here, and then on the next line I'm going to write the next conversion factor. So since molecules of air are on the top, we need to make sure that that cancels out to convert our units. Molecules of air. So if we have 78 molecules of nitrogen, that means that that is, in regular air, a total of 100 other, within 100 molecules of total air. And if we look at conversion, molecules of air converts to molecules of nitrogen. And that was, just to be clear, our orange conversion factor. So now if we go through this problem and we do these calculations, we see that 5.63 will be multiplied by 1 over 22.4 liters. This can be multiplied by Avogadro's number, 6.022 times 10 to the 23rd. It's going to be multiplied by 78 and then divided by 100. And if we do that, what I find is that we have 1.18 times 10 to the 23rd, and our final units are molecules of N2, or nitrogen. So we could also say that in Sia's breath at standard temperature and pressure, we have 5.63 liters of air is equal to 1.18 times 10 to the 23rd molecules of N2. Hopefully that'll help you answer all the questions in your homework and come prepared for class tomorrow.